We have our distribution of men and women heights given over here, and you've done this problem before, but here's a few more extra practice problems for you. If Anthony was 2 standard deviations above the mean, so Anthony being male, we look here at 2 standard deviations above the mean. How tall he would be, of course, is 73.9. Obviously not too tricky because he's perfectly on a standard deviation. So let's go to the next one. Now we have Anthony, and he's grown a little bit. He's 2.5 standard deviations above the mean. So 1, 2. He's somewhere in here. All right. Now there's a few ways you can solve this. You're thinking, well, he's halfway between these two numbers. Let's just average those. So we could take 76.6 plus 73.9 and cut it in half, and we should be able to find where his height lies. So we're going to do that. And we get him to be 75. I should probably divide by 2 here. We get him to be 75.25 inches tall. Now that's correct, and it's easy because he's a half. A perfect half makes this easy. But remember, if we were going to do it another way, remember that this measurement, every time in between these increments here, the green span, is always 2.7 inches. So another way to think about this, especially if it's not just a half where you're averaging them, we could take, so a separate way to do this, we could take 2.7 standard deviations is what one of those green chunks is worth. We want him not only to be worth 1, 2.5. You can again do this a couple different ways. I'm going to say that he's 1, 2.5 standard deviations. So I want 2.7 2.5 times. Now, if I do that, I get 6.75. Let's think about what that represents. That is 2.7 is how many inches a standard deviation is, and he's 2.5 of them away. So this is actually an inches measurement. That's how many inches it would be from here to here. In order to get his height then, we're going to add this to the average of 68.5, and we get the same answer of 75.25. As if that wasn't enough ways to do it, another way you could do it is you know he's going to be 1 and 2 standard deviations. You know he's at least 73.9. But we want to know what this half standard deviation is. So we could take half times a standard deviation, which is 2.7. We only want half of that. Kind of like if I wanted half of your 20 donuts, I'd take half of 20 and get 10, or half times 20. So if I take 2.7 times 0.5, I get 1.35. Now that's how many inches half a standard deviation is worth. So I would add that on to 73.5. Is that right? So 73.5, add that on because that is this number right there. Remember, I already knew he was that tall. And then I do that. Sorry, no wonder my calculations are off. My apologies. 73.9 is what we're looking for here, because that's how tall I knew he actually was. So 73.9. And that gives me, when I add it to my 1.35 and my 73.9, my 75.25. So a couple different ways there to convert a standard deviation that they give you into an actual height.